Hello viewers. In our last video, we're talking about matrix algebra, whereby I defined a matrix as a rectangular array of numbers that are arranged in rows and columns. We stopped at order of a matrix in our last video, so we'll continue from there. The order is the order of a matrix. Now, in an order of a matrix, we consider number of rows times number of columns. That's the formula to look for the order of a matrix. The number of rows times number of columns, where rows is simply horizontal, columns is the vertical line. Now, in this the given matrix A equal A11, A12, A21, A22 as the given entries of matrix A. Now, to start with, the horizontal or no number of rows in this given matrix is simply A11, A12, which is row 1 here, which is row 1 here, then A21, A22 as row 2. Now, to look for the column, number of columns is A11, A21, which is the vertical line, column 1. Now, A12, A22, column 2. Now, the order of this given matrix here is simply 2 times 2 or 2 by 2. It's of order 2 by 2 matrix. Now, note, put this at the back of your mind that anytime looking for the order of a matrix, number of rows comes first. Number of rows comes first, followed by the number of columns. Because if you do it the other way around, you will not get the answer. If you use column first, column times rows, it should be wrong. It is always number of rows as it is stated here. Number of rows times number of columns. You must follow it orderly. Now, this is number of rows. The matrix has 2 rows and 2 columns, which is this or this is simply acceptable. This or this is acceptable. Now, this is the order of this given matrix A is of order 2 by 2. Now B, this is a matrix B. These are the entries of the given matrix A11, A12, A13, and so on and so forth. Now, note that A11, this is A, this is the base, then A11 is the subscript. This thing is not equal to this thing here. Now, see the way I'm writing it. A11, this one here is the subscript. It's written below the A. Is not equal to A11. These are two different things. Now, if you want to write this what is it called? This entries, this A11, as you can see here, the way it's written there. So that is how. Okay, now this kind of matrix here is called a double suffix notation. This whereby A11, A12, A1 is written in this order. It's called a double suffix notation. Where this one here is represented as number of rows. This other one here is number of columns. Where A33 or A32 rather, A32, this is number of rows, this is number of columns. Okay, that is that by that. Now the question is, what is the order of this matrix? Now, from our previous example just now, see what I said. This number, row 1, row 2, row 3. Now, the number of rows there are 3. Quickly, without wasting time, number of rows there are 3. The number of columns here is 1, 2, 3. This is times 3. The order of this matrix B is equal to 3 by 3 order, or is of order 3. So that's that for that example. Now, another example, let's use K to represent the given matrix. Now, we have 4, 1, 3, 8, 2, 1, 4, 6, 4, 4, 1, 8. Now, what is the order of this matrix K? The order of this matrix K is simply number of rows times number of columns. Put it at the back of your mind. Number of rows comes first. 1, 2, 3. Now, we have 3 rows, which is 3, right now 3 times. What is the column here? We have column 1, 2, 3, 4. Now, the order of this matrix K is equal to 3 by 4 matrix. It's of order 3 by 4. That is the order of this matrix K. Now, note, let's try the other way around and see if we'll get the same answer. Because I said you must first write down the number of rows times number of columns. Now, let's do it the other way around and see if we get an answer. Now, let's do columns times rows. Now, what is the number of columns here? 1, 2, 3, 4 is 4. 4 times what? Number of rows is 3. So as you can see, obviously 3 times 4 is not equal 4 times 3 from the order. 3 comes first, 4 comes first. Now in the other way around, 4 comes first, 3 comes first. Now this is wrong, this is correct, because we are following the formula, which is number of rows times number of columns. Now this is more appropriate and is correct. So that's that for that. Another example, let's take this as an example. A equal 4. Now I'll count 5 to 0 for you to tell me the order of these matches before I will tell you the answer. 5, 4, 3, 2, 1, 0. Alright, let me tell you the answer to this order of these matches. Now this has only one entry to start with. This is just an entry 4. Now what is the order of these given matches? The order of these matches is simply number of rows is what? Is 1. Is row 1. Number of columns is also column 1. Now many of us will be wondering, why is it having rows, why is it having columns? Yeah, it has a row, it has a column. If it's just one, it has a row, it has a column. It's coming from the horizontal line, it's also coming from the vertical line. So this matches is of order 1 by 1 or 1 by 1. That's the order of this matrix 0, of this matrix 4. Now many more examples in the order of a matrix, whereby I can't just start writing. Okay, now coming from the previous one, which was a 3 by 3 matrix, 4 2 1 3 2 1 4 1 1. Okay, now this matrix here is known as a square matrix. It is also a 3 by 3 matrix. It's of order 3 by 3. Now, okay, that is that by that. Now let me do a 2 by 2 matrix. 4 2 3 1. Now this is a 2 by 2 matrix. This is a 2 by 2 matrix. Obviously a 2 by 2 matrix represented by k equal this. Now there's what we call determinant. I will quickly rush that. What we call determinant of a 2 by 2 matrix. How to find determinant of a 2 by 2 matrix? 2 by 2 determinant. 2 by 2 determinant. Now we have that the formula. Okay, let's use a double suffix notation to represent it. A11, A12, A21, A22. Now to look for the determinant of this matrix is simply this times this. Now in a type of matrix, there's what we call a leading diagonal. Coming from this other matrix, a 3 by 3 matrix, the leading diagonal of this matrix is simply 4 2 1. It's a principal diagonal. It's also called the principal diagonal or a leading diagonal. Now the off diagonal of this matrix is simply this. Coming like that. Now let's represent this matrix by A. Remember, you must present a matrix by any capital letter. It must be a bolding capital letter. Now the leading diagonal of this matrix also is like this. It's coming from the top right to the bottom left. From the top right to the bottom left. Now this is the principal diagonal of this matrix K. 4 and 1 are the leading diagonal. Now from this double suffix notation matrix, A11, A12, A21, A22, the leading diagonal is A11, A12. Now while the off diagonal is A12, A21. Now if somebody should ask you what is the leading diagonal of K, of this matrix K, you simply say 4 and 1 are the leading diagonal of this matrix K. Now moving on, finding the determinant of this 2 by 2 matrix, simply A11, A22 minus A12, A21. Now some people might be confused when I'm writing A11, A21. What is going on there? What is bringing them together? What is the law of binary operation that is connecting this A11 and A22 together? Now the binary operation is now coming from this. I will explain why it is like this. Now in a university, now back then in our secondary school, they will tell us that A11 times A22, it is written like this for us to see. Now in a university, they will not come and be writing times here for you to be seeing it that it is times. Now we'll tell you a secret. In a university, multiplication here is actually dots. When you see dots, A11 dot A22, this dot here, this dot yeah, means multiplication. Most times they will not write it, they'll just write A11, A22. Now the law of multiplication is actually dragging these two numbers together, A11, A12, is combining it together. That's the law of multiplication now, combining it together. Now you can also write it as A22, A11. You know why you can write it like this? Because the law of multiplication does not follow any order. The law of multiplication, now law of multiplication and addition is commutative. Now what do I mean by, if I say commutative, what do I mean by commutative is if I say A times B is equal B times A, it does not follow any pattern. Each way, any way. Okay, 4 times 2 is also equal 2 times 4. You will also get the same answer. You will get 8 here, you also get 8 here. Everything is equal 8. So you can see it does not follow any order. Either you write B, you write 2 first, 2 times 4, or you write 4 times 2, it's still equal the same 8, 8. It's still equal the same 8, 8. So it does not follow any order. The same thing applies with addition. Addition, when you have A plus B is equal B plus A. So now here is 4 plus 2 is equal 2 plus 4. You will still get the same answer as 6. This plus this. So it does not follow. Only minus, only subtraction is not commutative. The law of subtraction is not commutative. You should do it for this. Minus 2 equal 2 minus 4. You will not get the same answer. This is equal to, this is equal minus 2. Whereby minus 2 is not equal to, whereby 2 is not equal minus 2. So it's wrong. It's not the same thing. Now the law of commutativity only works for subtraction and multiplication. Now back to our matrix. That was just an explanation. Back to our matrix. Now you cannot know the reason why I'm writing A11, A22. The law of multiplication is connecting these two things together. Now minus this and this, minus A21, A22. Now anyone can come first. It's either A22 comes first or A11 comes first. You also get your answer. Now let's use a number. Let's use numbers to look for this determinant of a 2 by 2 matrix. Now coming from this formula, we can see that 4 times 2, I'll write it out for you to see. 4 times 2 minus 2 times 5. 2 times 5. Now this is 4 times 2 is 8. 2 times 2 is 8 minus 2 times 5, 10. Now is equal minus 2. Now the determinant of a 2 by 2 matrix of these entries is equal minus 2. So that's that for that. And that's going to be all for today's video. In our next video, we'll continue from where we stop. Thank you.